In this class, we're going to learn how to differentiate an implicit function. Okay, let's consider the question that we have on the board. We are asked to find the derivative of this function with respect to x. Okay, please pay attention. The first thing that you need to do is that you first have to identify the variable that you have in this equation. You have x and you have y, right? Yes. That means that in this question, we are differentiating y with respect to x. Do you understand? So because we are differentiating y with respect to x, anytime you differentiate y, you are going to multiply that derivative by dy dx. Do you understand? Okay. So let us proceed. Differentiate x squared. You're going to have 2x, right? Yes. Plus, okay. Now, differentiate 2y squared. You're going to have 4y. Now, because we are differentiating y with respect to x, we are differentiating y with respect to x. Anytime you differentiate y in this question or in this function, you are going to multiply that derivative by dy dx. Do you understand? So for this, I'm going to have this multiplied by dy over dx because now I differentiated y. So if you differentiate 1, you're going to have 0. So I'm going to have 0 here. Okay. The next step is that you have to make dy dx the subject of the formula. Okay. So I'm going to have 4y dy all over dx is equals to, now, this 2x, you move it to the right hand side of the equation. You're going to have minus 2x. Okay. Divide both sides by 4y. This over 4y and this over 4y. dy all over dx will be equals to negative x all over 2y. Are you getting it? Okay, because this will cancel this. I'm going to have 2y here. I'm going to have 1 here. Minus 1 times x will give minus x. 2 times y will be what? 2y. Okay. Do you understand the solution? Now, let's consider this question as well under implicit differentiation. We are asked to find the derivative of y with respect to x. Okay. Don't forget, because we are differentiating y with respect to x, anytime I differentiate y, I'm going to multiply that derivative by dy over dx. Do you understand? Okay, so differentiate x to the power of 3. You're going to have 3x squared, right? Okay, plus, now listen to me carefully. The second term here is what? X squared y. X squared is multiplying y. And in differential calculus, when we have two functions that are multiplying each other, you understand? When you have two terms that are multiplying each other, you have to use product rule. Do you know? So for this, I'm going to use product rule to differentiate x squared y. Okay, let us make use of product rule. The first part of this function, you have to keep it constant. Are you getting it? So I'm going to keep x squared. I'm going to keep it constant. I'm not going to differentiate x squared. Okay, so I'm going to have x squared multiplied by the derivative of y. If you differentiate y, you're going to have what? 1. Okay, so I'm going to have x squared multiplied by 1. Now, anytime you differentiate y, I told you, you are going to multiply that derivative by dy over dx. So because I keep x squared constant, I differentiate y. I have 1. Now, I'm going to multiply the derivative by dy over dx. Do you understand? Okay. Now, we are not done with the derivative. Okay. We are not done with the derivative of this. The first part, you keep it constant. The first part is what? X squared. You differentiate y, you have 1. Multiply that derivative by dy dx. Do you understand? Now, put additional sign. Keep the second part. Keep it constant. The second part is here, is y. So I'm going to have y multiplied by differentiate x squared. You're going to have what? 2x. So I'm going to have y multiplied by 2x. Do you understand? Okay. If you want to learn more of product rule, you can check the playlist on this channel. Okay. And you can check. You can also check the link in the description of this class. Okay. So for this, I'm going to have, now we still have another one, x, y. X is multiplying y. We are going to make use of product rule to differentiate it. Do you understand? And according to product rule, you have to keep the first part of this. You're going to keep it constant. X is the first part, so I'm not going to touch x. Keep it constant. Differentiate y. If you differentiate y, you're going to have 1. And anytime you differentiate y in this function, you're going to multiply that derivative by dy dx. So I'm going to have 1 times dy dx, that is dy over dx. Okay, plus, now you're going to keep y constant and differentiate x. Okay, so I'm going to have y multiplied by x. If you differentiate x, y multiplied by the derivative of x. If you differentiate x, you're going to have 1. 1 times y is what? Y. Do you understand? Okay, Now differentiate this. You're going to have plus 1. This will be equals to what? 0. This plus 1 is gotten from the derivative of x. Are you getting it? Okay. Now let us simplify. I'm going to have 3x squared plus x squared dy all over dx plus 2xy. Are you getting it? Plus x dy all over dx plus y plus 1 equals to 0. Okay. Now the next step is that you have to make dy dx the subject of the formula. And to do that, you have to collect like terms. The term that is attached to dy dx, you separate them from the other. You can see that dy dx is attached to x squared here, and dy dx is attached to x. So I'm going to separate them. I'm going to have x squared dy all over dx plus x dy all over dx will be equals to, okay, all other terms, move them to the right hand side of the equation. So this will be negative 3x squared, negative 2xy, negative y, and negative 1. Okay. Now the next step is that you have to factorize dy dx. So I'm going to have dy all over dx x squared plus x is equals to negative 3x squared minus 2xy minus y minus 1. Okay. Having gotten to this point, you divide both sides by what? X squared plus x. This over x squared plus x. So I'm going to have dy all over dx will be equals to negative 3x squared minus 2xy minus y minus 1 all over x squared plus x. You can see that it's simple. Yours is just to get the techniques behind the solution, okay? So if you are differentiating y with respect to x, you multiply the derivative of y by the derivative, you're going to multiply the derivative of y by dy dx. Do you understand? Now, let's now assume that it is x that we are differentiating with respect to y. That means that anytime you differentiate x in this function, you're going to multiply the derivative of x by dx over dy. Do you understand it? So that's it. Okay, now let's consider this question as well under implicit differentiation. Okay, we are asked to find the derivative of 8x raised to the power of 6 minus 27x raised to the power of 3 y raised to the power of 3 equals to 0. Okay, how do we take the derivative of this function? Well, to do that, because we are differentiating y with respect to x, anytime you differentiate y in this function, you're going to multiply that derivative by dy dx. Do not forget, okay? So for this, differentiate x to the power of 6. I'm going to have 48 x raised to the power of 7, raised to the power of 6, 5, sorry, minus 27. Okay, now, do you know that 27 is multiplying x raised to the power of 3 and y raised to the power of 3? Do you know? 27 is multiplying x to the power of 3, y to the power of 3. So I put it outside the bracket. Now I'm going to differentiate x to the power of 3 and y raised to the power of 3 using the product rule. Do you understand? So let us do that. According to product rule of differential calculus, you have to keep this x raised to the power of 3. You have to keep it constant because that is the first part of the function. So keep it constant. I'm going to have x to the power of 3 multiplied by the derivative of y raised to the power of 3. Derivative of y raised to the power of 3 is what? 3y squared. So I'm going to have times 3y squared. Now, anytime you differentiate y, you're going to multiply that derivative by dy dx. So I'm going to have multiply by dy all over dx, then put additional sign. Now, do you know that the first step here, you differentiate, you keep the first part, you keep this constant, and you differentiate y raised to the power of 3, yeah, right? Now, the next thing is that you are going to keep y raised to the power of 3. You are going to keep it constant. Why you differentiate x raised to the power of 3. So let's do that. I'm going to have y raised to the power of 3, differentiate x to the power of 3. You are going to have 3x squared. 3x squared, okay? This will be equals to 0. Are you getting it? Okay, for this, I'm going to have 48x raised to the power of 5 equals to minus 27 multiplied by, now, x raised to the power of 3 times 3y squared. You're going to have 3x to the power of 3, y raised to the power of 2, dy all over dx plus, okay, 3x raised to the power of 2, y raised to the power of 3. All this equals to 0. Do you understand? Okay, having gotten to this point, the next step is that you, this is 48. 48x raised to the power of 5. Now, Use this negative 27 to multiply all through. I'm going to have negative 81 x raised to the power of 3 y raised to the power of 2 dy all over dx negative 81 x raised to the power of 2 y raised to the power of 3 equals to 0. Okay, having gotten to this point, collect, separate the term that is attached to dy dx. You can see that this is the term. So you're going to have negative 81 x to the power of 3 y raised to the power of 2 dy all over dx equals to, now this to the right hand side. Take this to the right hand side. You're going to have negative 48x raised to the power of 5. Now what of this? You're going to have negative 81, positive, plus 81 x raised to the power of 2 y raised to the power of 3. Okay, from this point I'm going to divide all through by negative 81 x to the power of 3y squared, and this all over negative 81 x raised to the power of 3 y raised to the power of 2. Okay, dy all over dx will be equals to, now separate the fraction. You're going to have negative 48 x raised to the power of 5 all over negative 81 x raised to the power of 3 y raised to the power of 2, right? For this I'm going to have plus 81 x raised to the power of 2 y raised to the power of 3 all over minus 81 x raised to the power of 3 y raised to the power of 2. Okay, what I did was that I just separate the fraction. Are you getting it? So I've not done anything. So for this I'm going to have dy all over dx will be equals to, now 48x raised to the power of 5 all over 81x raised to the power of 3 y raised to the power of 2, right? Minus 81x raised to the power of 2 y raised to the power of 3 all over 81x raised to the power of 3 y raised to the power of 2. Are you getting it? You see, I've not done anything. I just separate the fraction. Okay, now having gotten to this point, you can factorize dy all over dx is equals to 3x multiplied by, this is 48, sorry, 48, 3x multiplied by 48, okay, 3x squared multiplied by 48, or 16, sorry, 16x raised to the power of 3. Then, do you know what I did? I just factorized 3x squared at the numerator. I factorized 3x squared at the numerator. 3x squared times this will give me this. So, what can I multiply by 3x squared to give me negative 81 x raised to the power of 2 y raised to the power of 3? That is what? 27. 27, okay, minus 27 x, no need of x again, y raised to the power of 3 all over 3x raised to the power of 2 multiplied by 27xy squared. Okay, so this will eliminate this. Are you getting it? So the final answer, or where should I put it? The final answer to this, dy all over dx will be equals to 16x to the power of 3 minus 27y raised to the power of 3 all over 27xy squared. Okay, that will be the final answer. Do you understand? And if you didn't understand, just listen to the explanation again. It's simple. When I got to this place, see, when I get to this place, I want you to understand that I want to eliminate the negative sign at the front of this. So I separate the fraction. So this negative sign cancel this negative sign. So I have this. Are you getting it? If you take the LCM again, you're going to have 48x to the power of 5 minus 81x raised to the power of 2 y raised to the power of 3. Are you getting it? So I factorize 3x raised to the power of 2. Then when I'm done with this cancel this. So I'm left with this, which is the final derivative of this function. Do you understand? Okay, so you can see that it is easy to differentiate an implicit function. Anytime you are asked to differentiate an implicit function, the first step is that you have to notice what you are differentiating and also what you are differentiating with respect to. In this question now, what we did was that we differentiate y with respect to x. That is, we find the derivative of y with respect to x. And if that is the case, whenever we differentiate y in any of the function, we multiply that derivative by dy dx. Do you understand? So that's what I did. And then you can proceed to solve. And anytime you anytime you encounter question of this kind, like maybe in the function you come across, maybe the terms are multiplying themselves, use product rule to differentiate it. Do you understand? Okay, that's another thing that I want you to take note. Okay, so now let's consider the following question on implicit differentiation. we are asked to find the derivative of y with respect to x in this function. Okay. Now, to do this, you're going to differentiate x squared. The derivative of x squared is 2x, so I'm going to have 2x plus, now, in the second term of this function, we have 3xy. If you want to differentiate this, put this 3 and then open a bracket. Differentiate xy with respect to y. That means that we are going to use product rule, right? Good. Let's consider the following question on implicit differentiation. We are asked to find the derivative of y with respect to x in this function. Okay, let's start with the first question. We have x squared plus 3xy equals to 7y. We write the function as this: x squared plus 3xy minus 7y equals to 0. Okay, all I did was that I just take this 7y to this side, okay, and the sign changes to negative. Do you understand? Okay, having done this, then differentiate it. Differentiate x squared, you're going to have what? 2x, right? Plus, now, you want to differentiate 3xy. Put this 3 and then open a bracket. Now, what is left for us is that we want to differentiate xy. The sign between x and y is a product sign. And anytime we have the term that are multiplying each other, we use product rule of differential calculus. Do you understand? So according to product rule of differential calculus, you have to keep x constant. I'm not going to touch x. Keep x constant. Differentiate y. And because in this function, we are differentiating y with respect to x, that means anytime we differentiate y, we're going to multiply the derivative of y with respect by dy dx. Do you understand? You're going to multiply the derivative of y by dy all over dx. Okay? So anytime you differentiate the term y, you're going to multiply the derivative of y by dy over dx. So keep x constant, differentiate y. If you differentiate y, you're going to have 1. 1 times dy dx, that is what? Dy all over dx, okay? Plus, now keep y constant. Keep y, keep it constant. I'm going to have y. Differentiate x. What are you going to have? That is 1. Y times 1, that is what? Y. Do you know how I got this? If you didn't understand, listen to the explanation again. We want to differentiate 3xy. I put this 3 outside the bracket. Are you getting it? Then I want to differentiate xy. To differentiate xy, we are going to make use of the product rule of differential calculus. According to product rule of differential calculus, the first part here, which is x, you keep it constant. You are going to differentiate y. So I have x. If you differentiate y, you're going to have 1, right? Yes. Now, anytime you differentiate y in this function, you are going to multiply that derivative by dy dx. Are you getting it? You are going to multiply the derivative of y by dy all over dx. So, having differentiate y, I got 1. 1 times dy dx will give me dy dx. Are you getting it? Then you have the additional sign. Now, you have to keep the second part, which is y. You are going to keep it constant. You are going to differentiate x. If you differentiate x, you are going to have 1. 1 times y, that is what? Y. Are you getting it? Okay. Minus, now differentiate 7y. You're going to have what? 7. And I told you that anytime you differentiate a component of y, any term that has y that is attached to y, you're going to multiply that derivative by dy dx. You can see that we have negative 7y. So if you differentiate negative 7y, you're going to have what? Negative 7 multiplied by dy all over dx. This will be equal to what? 0. Do you understand? Okay. For this, I'm going to have 2x plus 3x dy all over dx plus 3y minus 7 dy all over dx equals to 0. Okay. The next step is that you have to separate the term that is attached to dy dx. That is, I'm going to have 3x dy all over dx minus 7 dy all over dx is equals to, now, this will be negative 2x, while this will be what? Negative 3y. Okay? Now, factorize dy dx. I'm going to have dy all over dx multiplied by 3x minus 7 equals to negative 2x minus 3y. Okay? So to get dy dx, you divide both sides by what? 3x minus 7. So I'm going to have dy all over dx is equals to negative 2x minus 3y all over negative 2x minus 3y all over 3x minus 7, which is the final answer. Do you understand? If you didn't understand, kindly listen to the explanation again. Okay? So now let us look at the question that we have on the board. We are asked to find the derivative of y with respect to x in this function. Xy minus x squared equals to 3. Okay, to do this, since we are differentiating y with respect to x, anytime we differentiate y in this function, we are going to multiply the derivative of y by dy all over dx. Don't forget. The reason why I'm emphasizing on this is because so that you won't forget, and then at the end of the day, you won't get the correct answer. Do you understand? Okay, now let us differentiate xy. Because the sign between x and y is a product sign, we are going to make use of the product rule. And according to product rule, you keep x, you keep it constant, differentiate y. If you differentiate y, you're going to have 1. And anytime we differentiate y, we multiply that derivative by what? Dy over dx. So 1 times dy over dx will give me dy over dx. So I'm going to have multiply by dy all over dx, okay? Plus, now keep y, keep it constant. Y, differentiate x, you're going to have what? 1. 1 times y with what? Y. Do you understand? Okay? Minus 2x equals to 0. Because if you differentiate a constant, you're going to have 0, okay? Now, having gotten to this point, you're going to have x dy all over dx equals to 2x minus y. This over x, I'm going to have dy all over dx is equals to 2x minus y all over x. Okay, all through all over x. Okay, which is the final answer. Do you understand? Okay, let's look at the question that we have on the board. We are asked to differentiate y with respect to x in the function xy plus x plus y equals to 1. Okay, look at this. You are still going to make use of the product rule to differentiate this function. To differentiate xy, because the sign between x and y is what? Is a product sign. Do you understand? So keep x constant, differentiate y. You're going to have what? 1. 1 times dy dx, that is what? Dy over dx. Now, keep x constant, keep y constant, differentiate x. You're going to have what? 1. 1 times y, that is what? Y. Now, differentiate x, you're going to have what? 1. Differentiate y, you're going to have what? 1 times dy over dx. And 1 times dy dx is what? Dy dx. Do you understand? So I just put that one there to help you to understand that it is y that we differentiate, and the derivative of y will give me 1. And anytime we differentiate y in this function, we multiply the derivative by dy over dx. Anytime you differentiate a component of y in this function, you multiply the derivative by dy over dx. Do not forget, okay? So for this, I'm going to have equals to 0, because if you differentiate 1 is a constant, and the derivative of a constant is 0. Do you understand? Okay, so now having got to this point, the next step is that you have to separate the term that is attached to dy dx. Are you getting it? You bring them together. So I'm going to have x dy over dx plus 1 dy over dx is equals to minus 1 minus y, okay? Because I take this and this to the right hand side of the equation, the sign is going to change to negative. So factorize dy dx. X plus 1 equals to what? Minus 1 minus y, okay? Dy all over dx will be equals to minus 1 minus y all over x plus 1. Do you understand? Okay? So you can leave your answer like this. Are you getting it? So that is the solution to the question. In differentiating a function implicitly, the first step is that you have to identify what you are differentiating and what you are differentiating with respect to. In this function, we are differentiating y with respect to x. That means anytime we differentiate y in this function, anytime we differentiate a component of y in this function, you're going to multiply that derivative by dy over dx. Do you understand? Now, let's change it. Let's assume that we are differentiating x with respect to y. That means we're going to be having dx all over dy, right? That means anytime you differentiate a component of x in this function, you are going to multiply that derivative by dx all over dy. It's as simple as that, okay? So let's look at more work example under implicit differentiation, okay? Let's consider the question that we have on the board on implicit differentiation. We are asked to find the derivative of this function with respect to x, okay? In this function, to differentiate y with respect to x, we have to differentiate term by term, okay? Now let's start with x squared. If you want to differentiate x squared, you're going to have what? 2x. So I'm going to have 2x. Now, we want to differentiate 4xy. The first step is that put this 4 and then put a bracket. Are you getting it? Now, focus on xy. Differentiate xy. What are you going to have? You're going to have x multiplied by dy all over dx plus y. Do you know how I got this? I make use of product rule to differentiate xy. You have to keep x constant. Are you getting it? Find the derivative of y. And because in this function, we are differentiating y with respect to x, we are going to multiply the derivative of, anytime we take the derivative of any component of y, we are going to multiply that derivative by dy dx. So if you differentiate y, you're going to have what? 1. 1 times dy dx will give me dy dx. So that's why I have this. Now, you have to keep y, you have to keep it constant. Then you have to differentiate x. If you differentiate x, you're going to have what? 1. 1 times y will give me y. Do you understand? Okay. Now, differentiate minus y squared. You're going to have what? Minus 2y. And because in this function, anytime you differentiate a component of y, you're going to multiply that derivative by dy dx. So I'm going to have minus 2y multiplied by dy all over dx equals to what? 0. Okay. For this, I'm going to have 2x plus 4x dy all over dx plus 4y minus 2y dy all over dx equals to 0. Okay, having gotten to this point, the next step is that the term that is attached to dy dx, you separate them. So I'm going to have 4x dy all over dx minus 2y dy all over dx equals to, now these 2x, take it to the right hand side. I'm going to have negative 2x. What of this? Minus 4y. Are you getting it? Okay. The next step is that I'm going to divide or factorize dy dx. So I'm going to have dy all over dx 4x minus 2y equals to minus 2x minus 4y. Do you get it? So divide all through by 4x minus 2y. I'm going to have dy all over dx will be equals to minus 2x minus 4y all over 4x minus 2y. Okay. Now, having gotten to this point, you can factorize dy all over dx will be equals to, what is common to negative 2x and negative 4y? That is 2, right? So I'm going to have 2 multiplied by negative x minus 2y. This all over 2 also 2x minus y. Okay. So I'm going to have dy all over dx is equals to, this will eliminate this, minus x minus 2y all over 2x minus y. Okay, let's consider the question that we have on the board. We are asked to differentiate y with respect to x in this function, x squared plus 3y x raised to the power of 3 plus 4y equals to 7. Okay, differentiate x squared, you're going to have 2x. Now, because we have 3y x raised to the power of 3, the sign between all these terms is what? Is a product sign. So I'm going to differentiate it using product rule. Are you getting it? So for this, I'm going to have plus, put this 3 and put a bracket. Differentiate y x raised to the power of 3. Y x raised to the power of 3, the sign between them is the product sign, right? So you're going to make use of the product rule to differentiate it. Are you getting it? Now, according to product rule, you have to keep y, you have to keep it constant. So keep y constant, differentiate x raised to the power of 3. You're going to have what? 3x squared. 3x squared. Then put the addition sign. The next step is that you have to keep x raised to the power of 3. You have to keep it constant. So I'm going to have x raised to the power of 3. Differentiate y. If you differentiate y, you're going to have what? 1. And because we are differentiating y with respect to x, anytime we differentiate y in this function, we are going to multiply that derivative by dy dx. That is, anytime we differentiate a component of y in this function, you're going to multiply that derivative by dy dx. So since I'm differentiating y will give me 1. If I differentiate it, I'm going to multiply 1 by dy dx. 1 times dy dx will give me dy dx. So I'm going to have this multiplied dy over dx, okay? Plus, now we have 4y. Differentiate 4y, you're going to have what? 4. So I'm going to multiply 4 by dy dx equals to 0, because if you differentiate 7, you're going to have 0. 7 is a constant, so I'm going to have 2x plus 3 times y 3 3 times y times 3 times x to the power of 2. That is what? 9x to the power of 2y, right? Now 3 times x to the power of 3 dy dx, I'm going to have plus 3 x raised to the power of 3 dy all over dx, okay? Plus 4 dy all over dx. This will be equals to 0. Okay, having gotten to this point, the next step is that you have to separate the term that is attached to dy dx. You have to separate them. So I'm going to have 3x raised to the power of 3 dy all over dx plus 4 multiplied by dy all over dx is equals to minus 2x minus 9x raised to the power of 2y. Now, the next step is that you have to factorize dy dx. Are you getting it? Take dy dx out. I'm going to have dy all over dx multiplied by 3x raised to the power of 2 plus 4. Oh, sorry. 3x raised to the power of 3 plus 4 minus 2, okay, equals to minus 2x minus 9x raised to the power of 2y, okay? To get the value of dy dx, you have to divide all through by what? 3x raised to the power of 3 plus 4. So I'm going to have dy all over dx is equals to negative 2x minus 9x raised to the power of 2y all over 3x raised to the power of 3 plus 4. Okay? I hope you understand this. So dy dx is this. Okay, let's proceed to the next question. We are asked to differentiate x raised to the power of 4 plus y raised to the power of 4 plus 3xy raised to the power of 3 equals to 8 with respect to x. Now, differentiate x raised to the power of 4. You're going to have 4x raised to the power of 3. Differentiate y raised to the power of 4. You're going to have 4y raised to the power of 3. Now, because we are differentiating y with respect to x, I'm going to multiply this derivative by dy over dx. So I'm going to have this dx. Now, you want to differentiate 3xy raised to the power of 3. You are going to make use of product rule. So let us keep x constant. Differentiate y raised to the power 3. Derivative of y raised to the power 3 is 3y squared. So I'm going to have x multiplied by 3y squared. Now, because we differentiate y components, we're going to multiply that derivative by what? Dy over dx. So I'm going to have this multiplied by dy over dx, then plus. Now, the next step is that you have to keep y cube. You have to keep it constant. So I'm going to have y cube multiplied by derivative of x. If you differentiate x, you're going to have 1. 1 times y cube will give me y cube. Do you understand? So I'm going to have equals to what? 0. Okay? For this, I'm going to have 4x to the power of 3 plus 4y to the power of 3 multiplied by dy all over dx plus 9xy squared dy all over dx plus 3y raised to the power of 3 equals to what? 0. Okay? Having gotten to this point, the next step is that you have to separate the term that is attached to dy dx. Okay? Now, this term and this term is attached to dy dx. So I'm going to bring them together. So for this, I'm going to have 4y raised to the power of 3 dy all over dx plus 9xy squared dy all over dx is equals to, now, take this to the right hand side. You're going to have negative 4x raised to the power of 3. Now, take this to the right hand side. You're going to have negative 3x, negative 3y raised to the power of 3, okay? The next step is that you have to factorize dy dx, okay? You factorize the dy dx. So I'm going to have dy all over dx multiplied by 4y raised to the power 3 plus 9xy raised to the power 2 equals to minus 4x to the power of 3 minus 3y raised to the power 3. Okay, to get the value of dy dx, what do? You divide all through by 4y to the power of 3 plus 9xy raised to the power 2. So for this, I'm going to have dy all over dx is equals to negative 4x raised to the power 3 minus 3y raised to the power 3 all over 4x raised to the power 3 plus 9xy raised to the power 2. And that is the solution to the derivative of x raised to the power 4, y raised to the power 4 plus 3yx and 3xy raised to the power 3 equals to 8 with respect to x. Do you understand? Okay, so it's easier to find the derivative of an implicit function when you follow the process. You're going to get the right answer. Okay, so this will be the end of the class on implicit differentiation. If you want to learn more, there are many classes that I've already done on implicit differentiation. You can always check the channel. Just go to the playlist. You're going to see differential calculus and then click on it. You're going to see many videos that I've already done on this concept. Okay, so before you go, don't forget to hit the like button and subscribe to this channel, and also share the video and like the video. Drop comments, tell me what you learned in the video. Okay, see you in the next class.